The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
The Moon, a beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the moon was like many, many years ago. The moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon. The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the moon suddenly became brighter than the sun? Let's explore several scenarios. Scenario 1. If the moon becomes brighter than the sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon. Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull, so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth.
Imagine several of those affecting our home. But that's a topic for a completely different story.